In today's lesson 8.1, we're looking at inverse and joint variation. But first, let's think back to earlier in the school year when we were working with direct variation. In Algebra 1, we said y equals kx, and in Algebra 2, our textbook says y equals ax. We know as x increases, y increases, or as x decreases, y decreases. So they go in the same direction. Another thing about direct variation that we know is that if I have a coordinate plane, we know that it goes through, the line will go through the origin. So y equals ax goes through the origin. If I had y equals mx plus b, we can see this is slope-intercept and how very similar they look, but our direct variation is missing the y-intercept of b. Inverse variation, we have our constant of variation, the a or the k, in the numerator. So as x increases, y does the opposite, it decreases, or as x decreases, y increases. There's an inverse relationship between x and y. And we know x cannot be equal to 0. We can't have a 0 in the denominator. And we don't want our constant of variation to be 0 either, because then y is always just going to be equal to 0. So let's write an equation that relates x and y inversely. So if we want to isolate a, we're going to multiply both sides by 4. So a equals 28. So now I simply put that value back into y equals 28 over x. That's the equation. And then sometimes you'll be asked to put in a value for x or another value for y. So let's go ahead and do that. Let's say x is equal to -2, and we want to solve for y. Simply, we would just say y equals 28 divided by -2, so y equals -14. I've highlighted or noted some key points about direct variation and inverse variation. Okay, now we're going to be deciding what type of variation we have. So here, if I isolate my y, I add 3x to both sides, y equals 3x. We know that this is going to be direct variation. The next one, so we want to get it to look like one of these two, if we can. So if I multiply both sides by y, I get xy equals 3, because the y's cancel. Now I can divide both sides by x. So y equals 3 over x. So this is inverse variation. And we have one more. We're just going to subtract x from both sides. Y equals -x plus 5. This is in slope-intercept form, so this one is going to be neither. All right, in this problem, it says we're working with inverse variation. So we know that we need this equation. I subbed in the values for y and x. We know that this means a divided by 1/3, so a times 3 over 1. So 15 equals 3a, and then we divide both sides by 3, so a equals 5. All right, so now we know a equals 5. We're going to put that value back up into y equals a over x, so we end up with y equals 5 over x. But now it says find out what y is equal to when x equals 10. So, excuse me, this is y equals 5 over -10, so that simplifies to y equals -1/2. All right, so in this one, you're driving between Chicago and Minneapolis. We know it's a 400-mile trip. It says we have inverse variation, and it's asking us to write a model between Chicago and Minneapolis as a function. So we want t to be a function of the average driving speed r. So it's important to know that distance equals rate times time, and then we're going to go ahead and divide by r to isolate the t. So if I divide both sides by r, my new equation becomes t equals d over r. All right, so remember they told us that we were driving 400 miles, so that's the distance. So now we know that it's t equals 400 divided by r, our rate of speed. So in the next part, it gives us 32 miles per hour, 40, 50, and 60, and we just need to substitute these values into our t equals 400 over r and calculate the time. Okay, so on the right-hand side, I showed my work. I just substituted in the 32, the 40, the 50, and the 60 to get my answers, and I put them in the table. And you'll notice, remember for inverse variation, we said as one value increases, the other one decreases. So notice as our rate or our speed increases, our time actually decreases. And that's true for every single ordered pair. So in your notes, you should have your equations and examples for direct variation and inverse variation. And the final one we're going to look at today is joint variation. All right, while direct variation and inverse variation were covered in Algebra 1, joint variation was not. So for instance, this first one, z varies jointly with x and y, that would be written as z equals ax y, and a is a constant. Then we have the second one, p varies jointly with qrs, so that would be p equals a times q times r times s. All right, so it says variable z varies jointly with x and y, so it's written like this. It tells us the value for z, x, and y, so I subbed it in. So now we're just going to simplify. 60 equals negative 20a. We divide both sides by negative 20, so a equals negative 3. So now we're going to rewrite it as z equals negative 3xy. Now it's asking us to find z when x equals 7 and y equals 2. So we simply subbed in our x and y value, multiplied our 3 values, and got z equals negative 42. Last part, we're just writing the equation. So it says r varies inversely with s, so we would write that as r equals a over s. Another example, z varies jointly with u and v and inversely with the square of w. So z equals, we have our a, it's jointly, so uv, but it's inversely with w squared.